All right, so now we're going to start working on limits. So we have a left-hand limit. So this left-hand limit, you'll notice, has a negative sign in the exponent. That means we're coming from the left-hand side, so from where negative numbers are. A right-hand limit has a positive sign up in the exponent. That means we're coming from the positive side, or the right, where the positive numbers are. All right. So we will get an answer for this question, the limit as x approaches a, with no plus or minus. We'll get a number L if and only if, so you know that means we go both ways, if the left-hand limit and the right-hand limit give us the same number. So if the left-hand limit and the right-hand limit do not equal the same number, then that's when we say this limit does not exist as you're going towards a. So this is a graph I've drawn. So we're just going to work with this graph. So if you wanted to pause the video and draw this on your paper so that you had it to refer to, let's go. Oh, I forgot to label one point. Let me label that point -2. Okay. So let's go for it. So the way we say this, the limit of the function f of x, and this is the graph of f of x, as x approaches 2 from the left. Approach 2 from the left. So I'm going towards 2 from the left-hand side. So what we do is we jump on the graph and we say, what are the y values of the function approaching? The y values of the function are approaching 3. If I approach on the limit of the function f of x as x approaches 2 from the right-hand side, I'm going towards 2 from the right-hand side. I jump on the function. The y values of the function are approaching 3 as well. So what is the limit as x approaches 2? The limit as x approaches 2, since these two are the same, the answer is 3. So didn't ask it here, but if I was to ask you what is f of 2, what is the y value when x equals 2, that's 1. That's what this filled in dot is. But that's not what the limit is asking for. And we're going to be doing lots with limits. All right, let's do the same thing with 0. If I approach 0 from the positive side, go towards 0 from the positive side. You don't want to start too far away, within 1, because the limit gets really, really close. 0 from the positive side, jump on the graph. What are the y values approaching? They're approaching 1. If I go, the limit of the function is x's are approaching 0 from the left-hand side. Go towards 0 from the left-hand side, jump on the function. The y values are approaching the y value of 0. So since these two are not the same, this answer is does not exist. 0 and 1, they do not have the same limits. All right, this one, it's implied you have to do both. So when it says limit as x approaches 1, you have to go figure out from what both the left-hand and right-hand limit is. So let's just kind of write it down. But this would be implied that you would have to go figure this out. So notice you have to put the limit of the function as x approaches 1 from the left, from the negative. So from the left, from the negative, jump on the function's going to 3. If I was to take the limit of the function, x's are going towards 1 from the right, from the positive side, jump on the graph, the y values are going towards 1. So since these do not equal, this does not exist. All right, so let's look at what's happening towards -1. So if I'm going to take the limit as x goes towards -1 from the negative side, go towards -1 from the negative side, jump on the graph, the y values are going towards -2. I'm going to take the limit as x goes towards -1 from the positive side. From the positive side, jump on the graph, the y values are going towards -2. So since these two are the same, I'm going towards -2. These two are the same, I go towards the y value of -2. All right, so these are just asking what are the y values defined as. So when x is equal to -1, what is the y value defined as? Well, it does not exist. There is no point for the y value associated with x is -1. How about 1? When x is equal to 1, what is the y value that's associated? That's right there. That's 1. Let's finish off this page. So we've got to be careful. You can't play around. You don't write things like infinity squared or 1 over infinity squared on your paper. We think it, and many times I want you to think about the basic graphs. That's what people think of. So I want you to be like a mathematician, training you up that way. So thinking about the graph of y equal 1 over x. It's a basic graph. You should be able to get a quick picture in your head or on your paper what that looks like. So as x's are approaching 0 from the positive side, so you're coming in from the positive side, jump on the graph, the y values are going to positive infinity. If I'm going towards 0 from the negative side, jump on the graph, I'm going towards negative infinity. So as x's are going towards 0, this limit does not exist. The infinities do not equal. So what happens if I'm looking at 1 over x squared? I've actually filled this one in for you. So 1 over x squared, you know this is the graph. They're both going to infinity, right? As I'm going towards 0 from the negative or the positive, I go to positive infinity. So we say that this one has an answer of infinity. So we only get an answer of infinity or negative infinity if the left and right hand limits go to the same kind of infinity. So this is an example where these both went to positive infinity. So that's how I got this as an answer of positive infinity. I would get from negative and positive have to both be negative infinity for this one to say negative infinity. And so when a limit is going to infinity from either one side or from both sides, what we're looking at is a vertical asymptote, right? That's at x equals 0 is a vertical asymptote. All right, so let's look at this graph here. And you can pause it if you want to jot down some limits, but let's look and see what's happening. As I go towards 4 from the left, jump on the graph, the y values are going to negative infinity. Go towards 4 from the right, the y values are going towards negative infinity. So what's the limit as x goes towards 4 of the function? Negative infinity. All right, if I'm going towards negative 2 from the negative side, it's from this side, I'm going down to negative infinity. I'm going towards negative 2 from the positive side on this function. Coming in this way, I go up to positive infinity. So that means the limit as I'm going towards negative 2 does not exist because these infinities are different. This one, I'm not going to write down both parts, but it's implied you have to do both parts. So as I'm going towards 1, from both sides, I'm heading up to positive infinity. So the answer is positive infinity. So even just looking at this graph, I can see that the vertical asymptotes are negative 2, x equal 1, and x equal 4. All right, so when you're given a function like this, and you've got some limits to deal with, first question I want you to think of, is this a basic graph? Do you know how to quickly graph this? I think you do. This is going to be similar to the basic graph of 1 over x cubed, which you know looks like this. So let's graph this one. So this will be 3 will be where the vertical asymptote is. So it'll be here and here. Basic graph. The 2 just makes it go up twice as fast. Not a big deal. So as I'm going towards 3 from the left, I'm going to negative infinity. As I'm going to 3 from the positive, I'm going up to infinity. So since these are not the same, I get an answer of does not exist. So I do know that this, sorry I didn't go through this question, but I do know because of looking at this, I know that x equals 3 is a vertical asymptote because it makes the denominator 0. Denominator 0. So if I have a number over 0, not 0 over 0, but some other number over 0, that's when I know I have a vertical asymptote. If it's 0 over 0, that's going to be something else. We're going to do more work on that. More work. So that's not a vertical asymptote. A number over 0 gives me a vertical asymptote. All right, so let's look at this one here. So is this a basic graph? Is x over x minus 4 a basic graph? No, it is not a basic graph. Is there a vertical asymptote? Is there a number where the denominator equals 0 and the numerator is not 0? Yes, x equal 4. X equal 4 is a vertical asymptote because it makes the denominator 0 but not the numerator 0. All right, so I know whatever the graph looks like, at 4, there's a vertical asymptote. So now it's my job to figure out what's happening close to that 4. So if I'm going to go towards 4 from the left, now remember limits are really, really close, and if I'm moving towards a vertical asymptote, for sure I'm going to a positive infinity or a negative infinity. So I'm going to pick a number like 3.9, because that's going to be close to 4 from the left. So I'm not going to even figure out what the number is. I'm just looking to see if I get positive or negative. Because I know there's a vertical asymptote, I already know the answer is infinity. I'm just trying to figure out whether it's positive or negative infinity. So I know it's an answer of infinity, so I'm just figuring out the sign of the infinity. So if I put in 3.9, I get a positive. And if I put in 3.9 in here, 3.9 is 4, I get a negative. So this all told gives me a negative infinity as an answer, because I know the answer is infinity if I'm moving towards a vertical asymptote. Let's do this again. So if I'm moving towards 4 from the positive side, coming in towards 4 from the positive side, I'm going to choose a number like 4.1. Again, I know the answer is infinity. I'm just trying to figure out the sign of the infinity. So if I put in 4.1, I get a positive over a positive, so I get a positive infinity. So since these are not the same kinds of infinity, this is an answer of does not exist. I'm sorry, I got a really long video here. Let me just finish off this last one. So this is not a basic graph. Is there a number that makes the denominator 0 and the numerator not 0? Yes, x equaling negative 4. So x equal negative 4 is a vertical asymptote. So I'm not even going to draw, I'm just going to put negative 4 here. I know it's a vertical asymptote. So then I know these answers here will both be infinity. Oops. Both be infinity. So it's my job to figure out the sign of the infinities. So I know the answers is plus or minus infinity for both of these. So I just need to figure out the sign. So if I'm going towards negative 4 from the negative side, I'm picking a number like negative 4.1. Negative 4 from the negative side. So again, just figuring out the sign. This would give me a negative on the top, and I would get a negative on the bottom. So all told, this gives me a positive infinity as the answer. Okay, so I'm going to do the same thing over here, going towards negative 4 from the positive side. So I'm going to pick a number like negative 3.9. So negative 3.9, putting it in the top. Negative 3.9 plus 1 gives me a negative. Negative 3.9 plus a 4 cubed, that gives me a positive. So this gives me a negative infinity. So for the answer, this is does not exist.